When we have equilibrium constants that are in terms of pressures for gas phase reactions, it's sometimes more convenient to work with those in terms of concentrations. Or vice versa, if we have an equilibrium constant in terms of concentrations, it's sometimes easier to work with that in terms of pressures. And so it would be convenient to have a way to convert from an equilibrium constant in terms of pressure, which we denote by K sub P, to an equilibrium constant in terms of concentration, which we denote by K sub C. Let's see how we can do that using the gas phase reaction between nitrogen gas plus hydrogen gas to form ammonia. In general, we would express this equilibrium constant in terms of pressures because these are all gases. So I would have the pressure of ammonia squared divided by the pressure of nitrogen times the pressure of hydrogen cubed. However, I know that pressure times volume is equal to nRT for a gas. And the concentration is the number of moles divided by the volume. And so I can rearrange the gas equation to write N divided by V if I just divide both sides by V and then divide both sides by RT. And so N over V will be equal to P over RT. So the relationship between concentration and pressure is that concentration is RT, pressure over RT, or RT times the concentration is equal to the pressure. And so I could substitute into my expression for Kp in terms of the conversion from pressure to concentration, the relationship between pressure and concentration. So my Kp is going to be equal to R times T times the concentration of NH3 in this case, squared, divided by the pressure of nitrogen, which is R times T times the concentration of nitrogen, times the pressure of hydrogen, which is R times T times the concentration of hydrogen, and I need to raise that to the third power. So I can rearrange this expression to get all my RT terms together. And so I can write that Kp is equal to RT squared times the concentration of ammonia divided by, I have an RT term here and I have 3 RT terms here, and so I'm going to have RT to the 4th times the concentration of nitrogen times the concentration of hydrogen cubed. And I need to square my concentration of ammonia because the concentration of ammonia is squared. So now if I look at this, I can see that 2 factors of RT on the top are going to divide out with 2 factors of RT on the bottom. And so I can write this as the concentration of ammonia squared divided by RT raised to the 2nd power times the concentration of nitrogen times the concentration of hydrogen cubed. Now you'll notice that this combination of concentrations is exactly the equilibrium constant in terms of concentration. And so I can say that this is equal to the 1 over RT squared times the equilibrium constant in terms of concentrations. And so for this particular reaction, the relationship between the equilibrium constant in terms of pressures and the equilibrium constant in terms of concentrations is these factors of RT. Because the exponents on our equilibrium constant are always equal to the stoichiometric coefficients in our balanced reaction, the number of factors of RT that I will have in the numerator will be equal to the stoichiometric amount of gas that I have in my products. And the power of RT in the denominator will always be equal to the total number of moles of gas in my balanced reaction in the reactants, because the denominator represents reactants and the numerator represents products. So I have RT raised to this number of gas moles in my products divided by RT raised to the number of moles of gas in my reactants. And so when I divide out all the factors of RT that I'm able to divide out, what I'm really doing is taking the number of moles of gas in my products and subtracting the number of moles of gas in my reactants. And so if I really want to write this in general, I can express the relationship between Kp and Kc as RT times number of moles of gas in the products minus number of moles of gas in the reactants times Kc. I often call this quantity, that is number of moles at the end minus number of moles at the beginning, is often expressed as delta N. And so I could also write that Kp is equal to RT times delta N times Kc. And that is the way that we can convert from equilibrium constants in terms of pressure to equilibrium constants in terms of concentration.